So we're continuing in our series of videos on intermolecular forces. Our second intermolecular force in terms of strength is the dipole-dipole force. So let's zoom in here on the second row. This is the dipole force. All right, and this intermolecular force exists between molecules that are polar. It exists between polar molecules. So for example, let's draw two formaldehyde molecules. So I have a carbon, two hydrogens, and that carbon is double bonded to an oxygen. So we know that this molecule is polar. It takes on the molecular geometry of trigonal planar most closely, and that oxygen is much more electronegative than those hydrogens, and so we're going to end up with a partial negative charge on this side of the molecule and a partial positive charge over here, which is going to give us a dipole that points in this direction, although the magnitude of that dipole is probably not accurate. All right, so what happens is we get another formaldehyde molecule, so I'll draw a second one here now, that has the same dipole moment, partial negative on one side and partial positive on the other. The partial negative on this first formaldehyde molecule that I drew is going to be attracted to the partial positive on the second formaldehyde molecule that I drew, and that's your dipole-dipole force. Dipole-dipole force. All right, so if we look over here, we can see how this one is much stronger than the dispersion force. If we look at one molecule, formaldehyde, that I just drew, that is polar. So this one's polar. Apparently that looked like a triangle. This one is polar, and ethane is nonpolar. All right, but if we look at the boiling points, even though they're low by our standards, the boiling point of formaldehyde is much higher than the boiling point of ethane. Why is that? Well, ethane only has dispersion forces, which are weaker, and formaldehyde has dipole-dipole forces, which are much stronger than dispersion forces. All right, that means it takes a lot more energy to break apart two formaldehyde molecules than it would to break apart or to separate two ethane molecules. And you can look at that in terms of the melting point too. And all we're doing here is talking about the transition from liquid to gas or the transition from solid to liquid. But you see the same trend, right? Because in both cases, we're talking about trying to separate the molecules. Now, this is not just a categorical type of characteristic. It is, it exists on a spectrum. So what I'm trying to say is that if the dipole is stronger, so if there's more charge separation, then this force will also be stronger. So you can see from this plot that as the dipole moment increases of the molecule, the boiling point also increases.